Let us now study an important law in electrostatics, that is Gauss's law, also termed as Gauss's theorem. About Gauss law we can write that this law gives the analysis of electric flux from a closed surface and its relation with the enclosed charge. Let's first write down the statement of Gauss law and we'll understand it later. This Gauss law states that the total electric flux emerging out from a closed surface. Be careful that in case of Gauss law, closed surface is mandatory. We need to first consider a closed surface and then we analyze the total electric flux coming out from a closed surface. And this is equal to the product of sum of all enclosed charges by the surface and the constant parameter 1 by epsilon naught. This is the statement we use for Gauss's theorem. Say in a region if there are some charges placed like this, which are Q1 minus Q2, Q3 minus Q4 minus Q5, Q6 and so on. And say we consider a closed surface which encloses the two charges Q3 and minus Q5 and say the surface is named as M. Then we can say total electric flux coming out from the surface M is this flux coming out from the surface M, which can be calculated by the expression integration of E dot ds for the closed surface M. This is the way how we mathematically calculate. We consider a small elemental area ds on the surface and we find out the net electric field at this point where this ds is considered, which is due to all the charges in the region. And by calculating E dot ds for the overall surface M, we get the total flux coming out from the surface. And according to Gauss law, this total flux emerging out from the surface is equal to product of sum of the enclosed charges, which are Q3 and minus Q5. So it is written as sum of enclosed charges by epsilon naught because it is multiplied with the factor 1 by epsilon naught. So here it can be written as Q3 minus Q5 by epsilon naught. That is the total flux which is coming out, that can be given either by calculation of this flux by using electric field or directly by using Gauss law, that is the product of enclosed charges and 1 by epsilon naught. This is the way how we use Gauss law in various situations, and the surface on which this Gauss law is applied are generally termed as Gaussian surfaces. In this case here, this surface M is our Gaussian surface on which the Gauss law is applied. In continuation, let's write down some important points about Gauss law and its applications. All these points are quite useful in various situations of electrostatics. The very first point which you should always keep in mind that for a Gaussian surface on which we generally apply Gauss law is called Gaussian surface. For a Gaussian surface, if Gauss law is applied, we calculate the electric flux through the Gaussian surface in two ways. One is by integration of E dot ds for the closed surface, and it should be equals to the sum of all the enclosed charges by the surface by epsilon naught. So in this situation, always be careful that the total flux which is coming out from the Gaussian surface is only affected by the enclosed charges. These are the charges which are enclosed in the region. So these are only enclosed charges which are affecting the total flux coming out. But if we are calculating the flux by using the traditional method by integration of electric field over the given area, and always remember here this E vector is the electric field due to all the charges of system, because we know well that the electric flux gives the information about the total electric field of the system. So your flux must be calculated by using the total electric field of the system, not only by the enclosed charges. Several times students generally commit a mistake that this electric field is taken those of enclosed charges only, whereas in this situation electric field is due to all the charges but total flux is affected only by the enclosed charges. So be careful for this. And using this, another point which is also very important, which is based on this we can use, that is using Gauss law we can find the electric field due to some symmetric charge configurations. In upcoming sections, we are going to study that due to some symmetric charge configuration, in various ways we can apply Gauss law to find out the electric field strength due to the charge configuration. We'll take it up from the next sections, and this is applied in a way we already studied in the point number 1. Using this expression only, we find out the electric field. We use the enclosed charges to find out the flux, and we use an unknown electric field in flux calculation, and solving this expression of Gauss law we calculate the value of unknown electric field. We'll see it in the coming sections.